Here is solution to question number 4 of your test on rational functions, equations and inequalities. These are communication and thinking problems, and therefore you're supposed to write explanation for every statement you give. Okay, so we have to write a rational function of this form ax plus b over cx plus d such that has zeros at x equals to minus 1, a vertical asymptote at x equals to 0, and a horizontal asymptote at y equals to 1. So let's look into this function. So the function given to us is of the form of ax plus b divided by cx plus d. Now, has a 0 at x equals to minus 1. It means if I plug in minus 1 here, then everything should become 0, right? That is the first thing. Okay, so if I put minus 1 here, everything becomes, okay, so it has 0 at minus 1. So if I put minus 1 for x, then I should get 0. This is what it is. 0 means the numerator should be 0, right? That relates a and b. Okay, now the second condition is a vertical asymptote at x equals to 0. So if I put 0 here, then we get a vertical asymptote. Now, for vertical asymptote at x equals to 0, well, d should be 0, correct? And a horizontal asymptote at y equals to 1. Y equals to 1 is a horizontal asymptote. That means a and c are same values, correct? So actually speaking, from these three conditions, we can actually find all these variables. So let's start looking into them one by one. So I think the best place to start is with the vertical asymptote at x equals to 0. So when we say vertical asymptote at x equals to 0, that means denominator should be, so we are trying to develop our equation like this. Denominator should be only x, right? Why to have anything else, right? X equals to 0, we have a vertical asymptote, right? So that gives us an option that d is 0. So from here we can say, well, that means d equals to 0 and c equals to 1. So that is how we get c and d from this particular condition. And then we say, well, horizontal asymptote is y equals to 1. Now if horizontal asymptote is 1, that means a over c is 1. So a is equals to c, that means, right? Both should be same values. So horizontal asymptote of 1, so we say horizontal asymptote equals to 1. That means a and c is equal, right? So that means a and c is equal. So if I write a as equal to c, then that should be 1, right? So that means I have x plus b now here, right? So that kind of gives me this condition. Now the last condition is that has a 0 at x equals to minus 1. That means if I put x as minus 1, then I should get 0, right? So that means if I put x as minus 1, I should get 0. So what I will do is I'll try to solve this for x equals to minus 1. So let me put x equals to minus 1 and then solve it. If I put x as minus 1, I get minus 1 plus b over minus 1. Now if this is to be 0, that means what? That means b should be 1, right? So that means b equals to 1. So these are my parameters now. I can plug these parameters and then again check my result. So I get a is equal to c, which is 1, and I also get b as 1. So basically I get x plus 1 over x as my equation, correct? So that is how, because d is 0, right? D is 0. So d is 0 for us. So that is the equation which I get. Let's check it once again. That has a 0 at x equals to minus 1. If I put minus 1 plus 1 is 0. So yes, it has a 0, right? And minus 1 is valid for denominator. A vertical asymptote at x equals to 0. If I put 0 here, yes, it works. It works. And a horizontal asymptote at y equals to 1, their ratio is 1. Same, right? Same coefficients. So that also works. So this is the perfect equation, simplest of all, which represents in this form and follows all the conditions given to us, right? So that's the answer. Thank you.